Now let's talk about ventilation. Ventilation, or the movement of air, is very important. Just think about how you feel when you're in a space that feels and maybe smells like it has stale air. Here are some specific reasons why ventilation is important. Building occupants require a certain rate of fresh outside air for health. If the air is not refreshed, oxygen levels drop, causing stuffiness and even drowsiness. For this reason, there are standards that specify the rate of ventilation in litres per second per person, which should be supplied to each type of space. This type of ventilation can be provided by open windows, vents, or mechanical ventilation systems. The exhaust or extraction of fumes from kitchens, bathrooms, and garages also enters this category. The second use of ventilation is for its cooling capacity. If the outside air is cooler than the inside air, it will produce a cooling effect. In fact, even if the air is not cooler, the sensation of airflow across the occupant's skin will contribute to improving their thermal comfort by enhancing the body's sweating mechanism. Let's talk now about how buildings can be ventilated. Mechanical ventilation refers to ventilation by mechanical means, through a fan, exhaust, and supply. Thermal recovery by heat exchangers, which we discussed earlier, is an example of a technique to enhance the efficiency of mechanical ventilation. Natural ventilation strategies, on the other hand, optimize physics, such as wind and the fact that hot air has a lower density and rises, in order to design airflows through the building through carefully placed openings. To ensure that a natural ventilation strategy will maintain internal temperatures comfortable during the whole year, including on the hottest days, it is recommended to verify a planned natural ventilation strategy with dynamic building modelling or simulation. Cross-ventilation is simply the movement of air through a space, driven by multiple openings in the space. The direction and strength of wind will affect airflow. As hot air rises, cross-ventilation can also be boosted through a space by providing low-level openings for air to flow in and high-level openings for the hot air to exhaust, therefore creating a flow of air up and through the space. Stack ventilation makes use of the change in density of air with rising temperatures, with carefully placed openings in the facade for air to enter and exhaust depending on their relative height. Hybrid ventilation. So hybrid or mixed mode ventilation strategy is one that relies on natural ventilation for parts of the year and activates mechanical systems such as fans to maintain comfortable conditions at the hottest times. Another innovative application of ventilation. Take, for example, an auditorium with a large area and high ceilings. The auditorium can be designed to deliver cool, fresh air directly into the space where people are sitting by a fan directed at the area. This increases their personal comfort, even if the whole space is not at the same temperature. As the occupants heat up the air in the space, this hot and humid air rises through the principle of air stratification. The ceiling can be designed so that as the air rises, it is directed towards an opening at the highest level to take the hottest air out of the room and exhaust it to outside. So to summarize, the clean air is blown in by a fan, which is an active system that consumes energy, but the hot air is exhausted by passive means, which does not require any energy.